My name is Maida, and first of all, I'm going to start out by giving a little bit of introduction. When I was a kid, I wanted to be a paleontologist when I grew up. I still like dinosaurs a lot, but clearly I did not become a paleontologist. Instead, I'm the manager of community and technical content at Auth0, and I'm also an Angular Google developer expert. And so all of the samples in this talk are going to feature information about dinosaurs because I like them, my family likes them, my kid likes them, and I like to sort of sneak them into presentations like this. So hopefully you'll learn something about dinosaurs. The code snippets and demo videos in this talk are from an app that I built, which is available on GitHub, and I'm going to share the link at the end of the talk. So Angular components, right? We use these every day. They're everywhere. And in order to lay the groundwork for this talk, I'm going to first do a little bit of review, so bear with me if this is very familiar, but we're going to build up from there. So we'll start with a classic example. And the classic example starts with managing subscriptions from observables and ngOnInit and ngOnDestroy lifecycle hooks. So let's say that in our browser we have an app that looks like this. So we go to the API, we load data, and then we display it. We subscribe to a GET request observable, and we'll display a list of dinosaurs in child components. So our component class looks something like this. In our ngOnInit function, we're going to subscribe to a getDinos observable that's coming from a data service. And then we're going to set up a local property called DinoList, and this is just an array that contains the response. And then finally, the last thing we're going to do is we're going to unsubscribe in ngOnDestroy. So our component template might look like this. We're going to use ng4 to iterate over the list, and then we're going to input the dino data into the child component so that we can display it. Right? So this is a great starting point. It's basically where everybody starts out when they're learning how to use Angular components and getting data from a service and displaying it. It teaches us about managing observable subscriptions, and it also teaches us about ngOnInit and ngOnDestroy, which are the most commonly used lifecycle hooks. But what could we do if we wanted to improve this? Well, a few things that we could start with are async pipe, ngIfElse, and then we can use template reference variables. So now if we do a little bit of refactoring, in our class, we're going to create a DinoList observable instead of using a subscription. And then we can use the RxJS tap operator if we want to sort of manage side effects, like showing loading status or errors. And note, we're not using map here because we're not going to manipulate the shape of the data that's coming back. And our template might then look like this. So we're going to use async pipe on our DinoList observable, and then we can loop over the data and display the list of child components. This is very similar to what we did before. But we can use ngIfElse and template reference variables in order to execute some template logic more declaratively. So we can check for the existence of async data with ngIf, and then if there is no data, we can use the else clause of ngIfElse to show a noDinos template, and this is specified using a template reference variable. And this template block contains the logic to show our loading and error messaging. So why would we do this? Well, first of all, this is declarative. So the template is actually handling most of the logic. It's sort of alleviating a lot of stuff out of the class. Subscription and unsubscription takes place automatically. And it also handles async and real-time streams very elegantly with sort of no additional effort on our part. Okay, so that's a lot of basics, right? So now that we've covered some basics, we're going to dig a little bit deeper. And in order to explore some additional component features, we're going to talk about a pretty straightforward real-world use case, and that is something that appears very simple, and it's target links. So say we have this scenario. We have an API. We want to be able to fetch data from the API, and then we want to, in our app in the browser, we want to take that data and display it. We do this all the time as like daily life for single-page application developers, right? So now let's say that we have a particular item that we're interested in. We want to be able to jump to that item either by clicking on a target link or by changing the URL hash. And we're going to take a look at what happens out of the box if we try to just do this sort of in a very standard way. So as you can see from the title here, spoiler alert, this isn't going to work. But we're going to load the data. Once the data loads, we have our list. Now we can click on these links that have target links. You can see the hash changing in the URL, but nothing is happening. We're not actually scrolling to the items that we want to see. So it's not working. It's not working well how we want. So how do we fix this? Well, in order to enable the target links to behave the way we would expect them to, we're going to use a few things. We're going to use the viewChildren decorator. We can use the AfterViewInit lifecycle hook, and we can also use element references. So here's our template. And we're going to loop over the dinosaurs, the array, the very familiar, it's still the same. Now note that each item has an ID that matches the dinosaur name. And then for each dinosaur, we're going to just display a link. And this link has a hash fragment that says, so it's like hash dinosaur name, right? And now we're going to add a template reference variable to our ngFor looped element, and this is called dinoElement. And basically what this allows us to do is to use the viewChildren decorator in our class to, we can use this on our dinoElement reference variable in order to get a list of element references. And we're going to call this dinoElements list, and basically this is the list of all of the elements that are in that ngFor loop. So now in order to subscribe to the hash change, because we want to do something when that changes, right? We're going to import activated route, and then we're going to do something on the hash change. And activated route provides us with a fragment observable. So we can subscribe to that observable. And this observable is going to emit a value whenever the hash fragment changes. So we're going to use the fragment value in this example to update a local properties, just called scroll ID. And then we're going to pass in the dinoElements list to a function. In this example, we're calling it scroll to anchor. It's sort of off screen, but what it does is it compares the scroll ID to the list of element references and then jumps to the proper DOM element. So now, we load the data again. Once we get the data, we can click on the items. You can see the hash changing in the URL, and now we're actually getting the scrolling behavior that we would expect and want. And this will also work if we manually change the hash. So if we're already on this page, we can go to the URL and type in a different dinosaur name, and it'll go to the proper place. But that's not it. We also need to make sure that if we load the page with a hash already present initially, we need to be able to scroll to that element automatically once the data loads. So in order to do this, we can use a lifecycle hook called AfterViewInit. And this is a hook that's called after every change detection has run for a child. And what it essentially does is it's a way to tell us when the ngFor is done rendering. And if you're familiar with AngularJS, you've probably seen things like ngRepeat complete. It's sort of similar to that idea in our particular implementation, I should say. So we're going to import and implement AfterViewInit. We're going to set up our ngAfterViewInit function. And then note that our viewChildren dinoElements list has a changes observable. And we can subscribe to that changes observable. And then we can execute some functionality when it emits, right? So this happens when an element is added, removed, or moved in the list. But since we're not modifying the data after it's initially been loaded, this is only going to actually fire once in our particular case. And that is when the view is initialized, when we go from having undefined to some data present. So essentially, it's telling us when the ngFor has finished rendering for the first time. So in our particular case, we're going to check for the fragment ID that we want to scroll to, make sure there actually is one. We're going to run our scroll to anchor function that I talked about earlier, and then we can pass in the query list of element references. And this is the value that we get from the changes observable. And this is then going to jump to the proper item. And then the last thing we want to do is unsubscribe, because we actually don't need the subscription anymore after that first view initialization, because we're just trying to get, once the data has loaded, jump to the appropriate hash, right? So let's take a look at this in action. We're going to start from a different page here, obviously, because we need it on init. We're going to add a Spinosaurus hash, so it scrolls to Spinosaurus. Note, we're at the top of the page, it loaded with the hash, and we get the data loaded, but once the data is finished loading, it automatically jumps to the proper item. So now we have working target links, which is exactly what we wanted. So moving on, the next thing I'm going to talk about is content projection. And as of like a few minutes ago from Rob's talk, some of this stuff is probably going to change a little bit in Angular 7. So I guess keep that in mind. So can you raise your hand if you remember transclusion in AngularJS? Not that many people. Okay. So transclusion is still here, but now it's called content projection. And in my opinion, this is a much better name for it because it actually tells you what's happening. Transclusion was sort of a weird term that nobody could see it and understand automatically what it was going to do. So what content projection is elements, is components with content inside the element, projected in from the parent. So say we have a child component, it's got some data passed into it via an input. We can see that dyno input there. And then inside this component, as it's displaying in the parent, we actually have some projected content. This includes several different elements. It's got an anchor tag, we have a span with a class of icon, and then finally we have a paragraph with a directive on it. So here's what that child component's template actually looks like. And so we can use ngContent tags to tell the component where we want to display the projected content from the parent. And we can also specify exactly which content elements does this display where in the template. So we can do that using a select attribute. And as you can see, we're saying show the anchor tag here, show the thing with the class of icon here. And then any remaining content that's not specified by selector can just be shown all together in an ngContent tag without the select attribute. Or you could leave out the sort of top two and display everything all together. So now that we can display the projected content, we need to be able to access it in our child component class, maybe, theoretically. And if we do, then what we can do is use after content hooks. And these are hooks that concern content children, which are the child components that Angular projected from the parent into the child. So here's a little example. We're going to look at this visually first. Let's say we have a component, looks like this in the browser. Everything that's outlined in red is actually content projected into this component. The other data is coming in from an input. And so we have a title with a link, we've got an icon, and then we've got some special information, special highlighted information. So this is what the parent component template looks like while it's displaying this child component. We have our input with the featured dino object. It's just a single object that contains the information for that particular dinosaur. And then we have content that's projected into the child from the parent. So we have a link. Again, this is going to look very familiar to before, but now we're using sort of semi-real data. We have our icon, and then we have our highlighted info with the directive on it. So note that we also have template references here. So we have the template references on the link and the icon, and then we have a directive as well. So what these do, or in the browser, these are the elements that are being referenced. So really quickly, here's the link, here's the icon, and then here's that directive. So now what we can do is we can use the content child decorator to get access to this projected content in the child. So we can use content child on element references. So we have here our dino link, which happens to be an A tag. We have our dino icon, which is a span in this particular case. And then we also have the directive. So in order to give you a little example of what you can do with this is we can import and implement the after content init lifecycle hook, and then we'll set up our ngAfterContent init function. And then this function is going to run every time the projected content is initialized in the child component. So after initialization, then we have access to our content child members, and this includes the link and the icon elements that are projected in. And because these are element references, we can do things like access their native element properties. So for example, we're just logging the href and the inner text from the anchor and the span respectively, and then we can also access the content projected directive. And sort of what's neat about this is we can also access its properties and its methods. So we can actually run one of the methods, and we're going to change the highlight color to red on initialization. So in order to give you a little bit of context on the next example, let's say that we have our static data, and this is the data for one particular featured dinosaur. Then we're also going to have a list of dinosaurs that we're getting dynamically from an API. And then we have some content, and we want to project that content into both sets of data. So let's take a look at this in the browser. So we're going to load the data. We had our static data already, and now we already have access to our featured link here and our icon because the content has been initialized for this. And then we have access to our highlight directive. Note it's red because we told it to be red when it loads. The other data loads now it is here, and we have our lifecycle hook ran again because more content was initialized. We have a highlight directive that's dynamically attached to one of the other children that was loaded from the API, and then we also have an icon on a different item here. So if you see that this ran every time the content was initialized. So this is great. It gives us a way to do things with the projected content, as well as execute methods on projected directives. So now that we've covered projected content, I'm going to talk about sort of another way to get content into child components, which everybody's probably familiar with. It's inputs, but specifically we're going to talk about change detection on inputs. So we're going to talk about onPush. And with onPush, I'm also going to talk about the onChanges lifecycle hook. So Angular's default behavior is to run change detection on every component in the UI whenever anything changes. So in order to sort of visualize this, let's say that our whole application is a building, and each room in the building is a component. Let's say somebody is coming home, so they turn on a light, and this means that there's going to be a change in one of the components. Someone's going to physically enter a room. But now every single room in the whole building lights up to check to see if the person coming home is entering that room. And this is change detection running. So at the end of the day, only one room's actually occupied, only one person came home, so only one of the components actually underwent a change. In general, this change detection strategy works fine, but you can probably see, even just from that example, how this is not going to be performant anymore in a complex app. So is there a better way? Well, yes, of course there is. We could use onPush. So in order to visualize onPush, here's our app building with the component rooms. Somebody's coming home, a light turns on because the room's going to undergo a change. But then with onPush, this is actually the only location where change detection takes place. So that's great. But how did Angular sort of know that? How did this work? So we're going to look at the code really quick. We can choose a strategy of change detection on a per component basis, which is great because we can pick based on complexity. So we're going to import change detection strategy from Angular core. Then we're going to add the change detection property, change it to onPush. And in order to give context to the next little example I'm going to show you, here's a really short little story. So I have a son. Like I said, he loves dinosaurs also, and this is him at the Field Museum in Chicago. And as you can see, he's GDPR compliant here. But so once I asked about some of his favorite dinosaurs, and then immediately with extreme confidence, all the confidence of a 4-year-old, he said chicken nugget. And I'm not familiar with that dinosaur, so I said, what? And he said chicken nugget-saurus. So actually, he was referring to a real dinosaur. This is what he meant. This is a Giganotosaurus. So keeping that in mind, here's our example. We have a Giganotosaurus component. This is a child component. It's dumb. It has input and content projection. And then it lives in a smart parent component. So the smart parent fetches data from the API through a service. And then it has a form to display the name and info, or a form to update the name and info, and then it displays the child component. So here's the parent component. Everything highlighted belongs to the parent. The name is content projected into the child. And then here's the child component. And so the displayed data below the name is coming in from an input from the parent. So the template looks like this. The parent component is composed of the highlighted code here, which is most of it. The parent class gets async data, sets it up for usage. Then we have our form. And then we have our dino input data. And then finally, we have the link and the dinosaur name, which are content projected into the child. So again, really quickly, this is visually what the parent is. Then we have the child, and that gets input from the parent. And again, quickly, that's what it looks like. So how are we going to monitor the changes in the data that's flowing between these components? Well, we're going to use the onChanges lifecycle hook, and this detects changes to the input properties. So we'll import onChanges. We're going to set up the ngOnChanges function. And then in that function, for this example, we're just going to use a logger to log the current and previous input values to the console. So in the browser, this looks something like this. We're going to load our data. Once that's finished loading, we have the form, and then we're going to display the local data in the parent. It's this .dino in the middle here so we can see the JSON. We're going to change the name of this dinosaur to Chicken Nugget-saurus now. We're going to update the input as well. And now you can see that the name has changed locally, and it's changed in the child too because it's content projected. And now the info has changed locally, but the info that's coming through the input has not changed. So this is exactly what we told it to do when we said to use onPush, but obviously this isn't the right user experience. So in order to enable onPush, we're going to have to change the reference. So here's some of the code that we're using in the parent. Setting up an observable, we're getting the dyno data from a service. We're using tap to set a local class property with the API results, but now we're going to freeze this dyno object. And so once that is frozen, it means that the data can't be mutated. So what we need to do now is we need to examine anywhere that we're attempting to mutate this object. So here's our submit form method. This is the method that runs when we hit submit after we put in some updates into the form. And with the dyno object frozen, this isn't going to work because what we're doing here is we're changing the property values of this .dyno, and we can't do that anymore. So now on submit, we're going to get an error that looks like this, and this is a read-only error. It says can't assign read-only property of object, and this is good. It means the property or our dyno object is immutable, and so now we have class behavior that reflects the UI behavior. So if we go back to our submit method, we can't do this. We don't want to do this. Instead, what we're going to do is we need to update the reference. So we can use object assign to do this and merge the previous dyno object with our updated values from the form. So now if we take another look at our app with these changes in place, we are going to load the data. We have the data here showing, and then we're going to update the name. We're going to change it to Chicken Nuggetsaurus again. And then we're also going to update the info. This time we're going to say tastier than ever. We're going to update, and now you see on changes ran. So we have our name of the dinosaur updated. The name has changed in the content projection, which is expected, but we also have our on changes information with the current and the previous, meaning that our child understands that something was changed in the input that it's getting from the parent. Same thing for the info, but now we have the info updated in the child as well. So yay, at this point, change detection only ran when we explicitly told it to, and we did that by updating the reference. And this is a super simplified example, but if you think back to this analogy, you can easily imagine how much more performant it is to not have to turn on all the lights every time somebody walks in. And the last thing I'm going to talk about just real quickly here is doCheck, and this is almost sort of a side note, but doCheck is a lifecycle hook that is used to detect and act on changes that Angular doesn't catch on its own. So it's called after every change detection cycle, no matter where the change occurred. And you can basically do this to set up custom change detection. This is particularly useful when you're using onPush. So it basically tells us the extent of the changes that Angular is capable of detecting when it's using zones. For example, we could use doCheck to detect object mutations and then manually mark them for check. But you have to be careful with this, especially if you're using onPush, because you did onPush to sort of avoid unnecessary change detection. So if you're going to then check for these type of mutations anyway, then you're defeating the purpose. So you want to be careful, don't do that. But it's useful if you need to do something special. So wrapping up, the last thing that I have in the example repo is optimistic updates. And I don't have time to cover this today, but we can combine everything we've learned so far, plus a little bit more to implement this. And it's example number 9 on the repo, so you can check out the code, you can take a look at what that looks like. So the GitHub repo, as promised, is located here. And then the slides are here. And that's all I've got for you today. Thank you.
Thank you very much to Kim.